Here's a problem that's presented to us graphically. We're asked to take vector 1, call this one vector 1, and vector 2, and both show what the resultant looks like on this diagram, but also we'll use the algebraic method to calculate the resultant, both the magnitude, of course, and the direction. One thing we have to pay attention to here is that the values given for the angles may not be the ones that we're going to use in our calculation. So some things are fairly straightforward. Vector 1 has a magnitude of 54 kilometers, and vector 2 has a magnitude of 64.5 kilometers. This is a displacement problem. How far did you travel and in which direction? We can think of this as points on a compass: north, east, south, and west. So here we traveled 54 degrees northwest, 18 degrees west of north. But when we enter this into our calculation, we have to ensure that we're giving our calculator the information correctly, which means we need to give the angle in standard position. So the angle that we're going to report for vector 1 is not 18 degrees, but rather starting at the positive x-axis. So in this case, we're given, this isn't the reference angle, this is just 18 degrees off of the y-angle. We've got an angle of 90 plus 18, or 108 degrees. So for vector 1, to find the x component, we'll use 54 times the cosine of 108 degrees. And to find the y component, we'll use 54 times the sine of 108 degrees. Similarly, we're told that vector 2 is just south of east, or just below the positive x-axis. We're given this dotted line here to show us where the horizontal is. In other words, if we picked up vector 2 and started its tail at the origin, we'd be drawing it down here. And it's this angle in here, down from the positive x-axis, that has an absolute value of 15.6 degrees. Okay, 15.6 degrees, if I tell you that angle, you're going to picture that as being in the first quadrant. But based on this picture, it's in the fourth quadrant. So we have a choice. We're either going to call this an angle of negative 15.6 degrees to indicate that we're starting on the positive x-axis and traveling clockwise, or we can use 360 degrees minus 15.6 degrees and indicate that this is, again, a quadrant 3 angle, and call it 344.4 degrees. 344.4 degrees. You can use either in the calculation. So you can indicate that the x component is 64.5 times the cosine of negative 15.6 degrees, or 64.5 times the cosine of 344.4 degrees. 344.4 and negative 15.6 are coterminal angles. So the cosine of these two angles will be the same. Down here, I'll write it down as 344.4 degrees. Again, you can do exactly the same thing for the y component. You can use either 64 times the sine of negative 15.6 degrees, or 64.5 times the sine of 344.4 degrees. We're just going to add them up. Adding up the x components, and I'm just dropping them into my calculator as is. So using only one of the ways to calculate the x component for vector 2, of course, we find an x component of the resultant of 45.437 and a y component of 34.012. Based just on the components, the fact that the x component is positive and the y component is positive, I know that my resultant is in quadrant 1. But here it's very easy to tell this from the picture as well. I can see, because I only have these two angles and they're already drawn tip to tail, they're set up to use the polygon method for adding vectors. My resultant looks like this. So I know it's going to be in quadrant 1. So I know that as soon as I calculate the angle using the inverse tangent, I have the final I have the final direction for the resultant. This will be theta r. It's nice to have a quadrant 1 angle. It takes away one step from doing these problems. All right, what is the magnitude and the resultant? Well, the magnitude, that's going to be the square root of the sum of the square of the other two sides. So we find we have a magnitude of 56.8 kilometers. What about the direction? We take the inverse tangent, and therefore that's going to be 34.012 y over x. So 34.012 over 45.437. I'm not worried about writing absolute value bars here because this ratio is already positive. So this vector is directed at 36.8 degrees. Again, we need both pieces for the final answer, and I'll summarize it down here. So the resultant vector is 56.8 kilometers directed at 36.8 degrees. And I've drawn it and labeled it on the diagram as well.